This particular graph there is what actually happens to our components. Let me just bring this down. This is the life curve of our roller bearing based upon the interference fit within that bearing. And what it's saying is this particular bearing is a ball bearing, and to get full life, to get a life of 1, the full design life, the interference fit required is a small preload of about minus 15 microns, about half a thou preload. So actually you've got to push these ball bearings together intentionally about half a thou at operating temperature to get the full service life. If I go 10 microns more, if I go from minus 15 now to minus 25, then I am down to 0.6 life. Another half a thou. Go another half a thou more, I'm down to 0.2 life. So when I have this situation of the situation here, where I'm pushing these things together more than half a thou, then I'm driving these ball bearings up and down that curve. These ball bearings and these elements here going up and down that curve, 3,000 times a second for a 2-pole and 1,500 times a second for a 4-pole. So I'm actually causing that bearing to fail from the high stress it gets from the out of roundness shaft. Because this is a laboratory result curve. This is telling us if I squeeze that bearing too much together, I will fail that bearing much, much earlier than its full service life. And if I've made the bearing too loose, if I actually put a gap in there on purpose, I'm on this side of the curve. I'm still losing a great deal of service life. So when it comes to machines with bearings, I have about 10 microns, 15 microns to play with. I've got half a thou to play with. And I've got to be in this zone here for the entire operating life of that machine. Now I've got to build a process in my company to make that happen. I've got to make sure that every single bearing is in its zone for full service life, and we do that on purpose, not by accident. Because by accident I could be too much overload or not enough. So I've got to design a process to make sure the right thing happens every single time. Because when it's wrong, either too much load, not enough clearance, the machine, she fails too early. And that's how our machines are designed. That's the way they all work.